Hi. For this lesson, I want us to work through the questions that are on pages 24 and 25 of your booklets. So this is having a go at the homework task that I've given you. And this is all about putting yourself in the shoes of a petroleum geologist. Can you interpret the data that a petroleum geologist might be working with? Okay, let's go. I've given you examples from two different hydrocarbon traps. This is the first one, which is question 12 on page 24. Take careful note of the scale and also think about the properties of these rocks. You might want to use the graph that's at the bottom of page 25 to help you to interpret this. Question 13 then has another hydrocarbon trap. Notice the scale on this one is quite different, but again you can think about the properties of these materials, of these different rocks that we find here. Have a go at answering those questions. And finally is the graph showing the relationship between porosity and permeability for different types of rock. You might even want to think about why this is as well. Okay, there's not much to explain for this. We've done all the theory as we've worked through this topic. Have a go at those questions, see what you can come up with. Okay then, let's have a look at some answers. So this is question 12. We have this oil trap. We're told that oil is present to a depth of 2.5 kilometers below the surface. So that's in about there. Notice it's a horizontal line because remember the oil is moving upwards. So the oil and any gas that might be present is above that line. Below that line, we're going to find water. Now this particular oil trap is an unconformity trap. You can see the red shale there cuts across the black shale and the sandstone, and there's an erosional surface there. There's definitely a break in the geology. Now the properties we need for the sandstone, for it to be suitable, is that it needs to be porous so it can store the oil, and it needs to be permeable as well so that that oil can be extracted and it can flow through that reservoir rock. If the reservoir isn't porous, it can't be a reservoir. If it's not permeable, there is something we can do about that. We could frack the rock to try and extract the oil. But that's going to be a much bigger job, much more expensive. The red shale then, if that's going to be our cap rock, then that needs to be impermeable. Question E then asks about a seismic survey. Now, a seismic survey is a way of seeing the geological structure beneath the ground. This diagram shows us a land survey where you've got a truck there creating seismic waves, hitting the ground with a large weight, triggering a small earthquake, a measurable seismic shock rather than anything you can feel. Those waves then go down through the rock into the ground until they hit a layer that's got a different density to the first layer. So the wave then can be reflected back to the surface, or can be refracted back. And this will happen at different depths, and we can work out we can measure the time it takes for the wave to go from its source down to the layer within the ground, and then back to the geophone where it's received. We can measure that time. We know how fast these things go, so we can then calculate the depth that these different layers are going to be at. With enough of these measured, we get a picture, an image, I suppose, in the seismic section of the structure of the geology underground. It's a very, very effective tool for locating geological structures. Remember, though, that seismic surveying doesn't find oil. All it does is find the geological structures that can form hydrocarbon traps. The only way to prove that there's oil there is to go and drill a hole. Okay. Question 13 then has a different type of trap. The trap we can see there at R is an anticline trap. You can see that the sandstone there has been folded, it's been bent into an anticline. The cap rock then for trap R is halite. And there is a different oil and gas trap that we can see in this location. That's where we're likely to find it. That's the salt dome trap. We then have this graph. I think we've really already worked out, to be honest, the properties of these. Sandstone, in this case, has a high porosity and a high permeability. It's what makes it so good as a reservoir rock. And shale, which we've seen as a cap rock, has low porosity and low permeability. Okay then, let's have a look at the exam practice questions as well. So we've got this cross-section of hydrocarbon trap drawn from a seismic survey. Oil trap J is clearly an anticline. Of all of these things, there's one of these factors that isn't involved in the formation of oil and gas reservoirs. And it's the seepage of oil at the surface. This can happen. It's what we call an oil seep. But hydrocarbons need to migrate. They need to move through a reservoir rock to accumulate. We do need a trap then to let that oil accumulate in sufficient quantity. We need the organic material to be deposited to act as our source rock for our oil. And finally, we do need this organic material to be heated up to lowish temperatures, but it needs to start breaking down the hydrocarbons to make the shorter oil and gas hydrocarbon chains that make them useful and valuable. It's a process we call maturation. All of these things can be done as part of the exploration process for oil, but there's only one thing that proves it, and that's actually finding oil from the hole that you drill as a result of all the other work you do. For question 2, extraction of oil can cause damage to the environment, particularly if it's done poorly. But there's one of these things that doesn't cause damage, and that's geological mapping. The rest of them can cause problems. And finally, depleted oil and gas fields are suitable for the storage of carbon dioxide, I think, because of three key things. Firstly, porous reservoir rocks, so the pores can store the CO2. Secondly, impermeable cap rocks that prevent the carbon dioxide leaking back to the surface. And finally, a geological structure that creates a space large enough for significant quantities of CO2 to be stored. Okay, there's one more job I'd like you to do before we finish this lesson, and that's to have a go at what's in a word. We've now covered all the theory we need for our use of sedimentary rocks, how we can find and extract the fluids, whether that's water, oil or gas, within these types of rocks that we rely on so much. So having worked through all our theory, we should now be geological experts and to come up with a really tight definition for each of those different terms. Okay, that brings us to the end of theme 4. I know we have some loose ends to tie up. Hopefully we'll be able to do that in class fairly soon. I'll see you then.